Lesson 7U. This is just a conic sections review. What we're going to do today is we're going to look at some equations and talk about how to graph using the calculator. We've been doing this algebraically in the lessons 7.1, 7.2, and 7.3, and so this one's just an extra lesson that we're going to use the calculator for. So it says graph and determine the foci and vertices of this equation. Now, what I'm going to point out is first off, to graph these in the calculator, what helps is this either needs to be in what's called general form. That just means where it's all x's and y's, no parentheses, no groupings, squared, or it needs to be in one of the forms that matches our formula chart. And I'm going to pull those up here. If I go to the formula chart front page, you see that we have our shapes down in here in conic sections. As a reminder, what makes parabolas unique is that it's only one squared. What makes an ellipse unique is that there's two squareds and a positive symbol between the two. And then a hyperbola is both xa and y squared again, but this time it's negative. A circle would be like an ellipse with the positive, the two squareds. It's just that these two numbers underneath would be the same, and so then they would just multiply them over here. That would be called your radius squared. So let's look at this. I see a y squared and an x squared, and there's a negative symbol, which tells me this is a hyperbola. Now, because the y comes first, it's going to be over here. It's a vertical hyperbola. So I'm going to get it totally in this form for the calculator, which means I need to make it equal to 1. So over here, to make it equal to 1, what I'm going to do is I'm going to divide by 144. When I do that, I have y minus 2 squared over, and how many times does 16 go into 144? Well, I could check on my calculator. Clear this real quick. 144 divided by 16 is 9. That means that 16 goes into 144 9 times. So 9's down here, minus, this would be x plus 3 squared over. Well, if 16 went into 144 9 times, that means the 9 goes in 144 16 times. So 16 would go there. Now, we've learned in the previous lessons, this means go up 2, because it's inside, it's opposite, so I'd go up 2 units. This would tell me go left 3 units, so 1, 2, 3, up 2. This will be my center. We've learned about taking the square root of 9 to go left 3. That would be a point, or a vertice rather, and right 3, that's a vertice. And then we'd go up and down 4, but since it's a hyperbola, we would go from here. But the whole thing that I want to point out today is we actually don't have to do it this way. We can use the calculator. So how do we do so? We go to our calculator. I'm going to go to this graph. Now this is in function notation. What we're graphing is not a function, it's a conic section. To get to that, you press menu and go to choose graph entry. Here we're going to choose equation. In equation, we see our 4 shapes: parabola, circle, ellipse, and hyperbola. We want a hyperbola, and our y is positive. So I'm going to choose the north-south, which just means vertical. The y is positive rather than this one. The x is positive, y is negative. So I choose that. Now our equation is y minus 2. This is preloaded with y minus, so all I have to do is hit a 2 there. Now over here, it says x minus. My equation says x plus 3. So one of the main ways I've seen people mess this up is they put plus 3 there. Now we have x minus plus 3. That, a minus plus, becomes a minus. So that doesn't work. What you actually have to do is type in like a negative 3. Now you have x minus a negative 3. 2 negatives make a positive. That'll turn it positive. The other way people mess up is they miss that there's a square here, but not here. So you either need to do one of two things. You need to recognize that 9 is the same thing as 3 squared, and 16 is 4 squared, and type in here 3 and 4 in the other, and graph it. Or, let me pull that back up, we need to type in down here, instead of typing in that, you can stick with the 9, but you just have to put square root 9. Now the square root and the square will cancel each other. I'll do that over here. Square root 16. This should give me, why did it move? This should give me the same graph I just had when I press enter. So we see it, we notice it's the same. Again, my center is left 3, up 2, just like we had. There's my hyperbola. Now the problem asked us not just to graph that hyperbola, but also we do have to graph it and determine the foci and vertices. here's what the calculator can do for us. If we go to Menu, choose Analyze Graph, go to Analyze Conics, we can find foci and vertices. When you choose, I'll choose vertices first. You highlight the shape, press Enter, and it'll give you the 2 points. Those are my vertices. So I should have a point. You know what I messed up here is I went left and right 3, but that was under Y. I should have been going up 3 and down 3. That's why it's helpful to have a calculator. So that's where those points came from. It was -3, 5, and -3, -1. That was the points the calculator said. Now let's find foci. So we go back to Menu, press Analyze Graph, Analyze a Conic, choose foci. I hit Enter. It'll pull those up. And I'm going to shift this way so we can see it a little bit easier. So I have -3, 7 and -3, 3. So back over here, my foci would be located at -3, 7, which is here. That's the foci. And then this one is down 2 units as well, and it was -3, -3. That's my other foci. And the vertices would just, or the hyperbolas would open around them. And to help you out, if you needed some help, you can also find other things, such as we could find an asymptote by going Menu, Analyze Graph, and choose Asymptote. Oh, Analyze Conics, sorry. Asymptotes. Highlight the shape. And this would tell us that our slope is -3/4, and this one's +3/4, which just means from the center we're going up 3/4. So my asymptote is going to, this is going to go here. It will go up 3, 1, 2, 3 over 4, 1, 2, 3, 4. And the other one was going to go down 3, 2, 3 over 4, like that. So these are how my asymptotes are going to pass. And if I need to complete the x, well, since I went 4 this way, I'd also go 4 this way and 4 this way. Now I could add asymptotes and have a complete graph here. So there's that asymptote. This asymptote would go this way. And now your graph would start at the vertice and curve up along the asymptote and curve along this asymptote as well. Here the same. And there's the same. So we now graphed and we determined the foci and vertice. Now I have a few for you to try.